Good day, my students. How are you doing? Hope you are feeling fine. The topic before me this afternoon is sets. This particular topic is very, very important because it will come out in your work, it will come out in NECO, you will come across it in JAM. That is why you must take it very serious. Maybe you have been taught sets when you are in SS1. There's no any teacher will teach you when you get to SS2 or SS3, but you come across it in your work examination. So it's very, very important, and that is why we need to take it very serious. What is a set? A set is well defined as collection of objects. It is denoted with capital letter, while the element is being denoted with small letters. We have different kinds of sets. But what's like your bag is a set. What you can find in your bag is the element. And if you want to write it, you write it with small letters. Now, let's take as an example, zoo is a set. When you have zoo, now let me ask you a question. What are the objects? What can you find in the zoo? Yes, tiger, you write it with small letter. Yes, lion. Yes, leopard, but I don't want to use leopard again. Then what other? You say what? Tiger. I don't want to use, tiger is already here. I want to hear from you. Can we find cats? Yes. Cat is there. And so forth. Now, as I've defined sets, a set is well defined as collection of objects. It is denoted with capital letter as in Z. Z as in zoo. While the element is being denoted with small letters. Now, if you want to write this now, you write Z. What are the elements? What can you find there is T, L, and C, and so on and so forth. But before we move a little bit higher on the set, you're supposed to know the set notation. Set notation. That is what we use to describe sets. So you should be conversant with the notation. Like this, we have what we call universal sets, or like this. This is what we call empty sets. This is what we call contain or belongs. So if I cross this one now, can you tell me what it means? If this is contain, this one will be does not contain. Or does not belongs. Then we have what we call intersection. We have what we call union. Then I made mention of empty sets here, or you can take this form as well. Then we have equal to. So if I cross this, means does not equal to we have less than or greater than, less equal to, greater equal to, we have what we call there exists. This there exists. This is such that we have what we call A prime and A complements. A prime or A complements. When we say A prime or A complement, maybe I decide to give Sawa and Kainde and something 20,000 naira, and I said A intersection B intersection something prime. I made use of this, meaning that I don't want something to share from the money. That is what it means. It's either you use A prime or A complement. So you don't want to give either the third party, or you don't want them to share. So that's that. Now let's quickly move to the set. As I've said earlier, I told you that we have different kind of sets. I want you to think about it. Sets. What about your mommy kitchen? Your mommy kitchen is a set. What are the elements that you can find in your mommy's kitchen? Think about another thing. What about wardrobe? Your wardrobe is a set. What are the items that you can find in the wardrobe? So I want you to list 10 sets and the elements. Okay? That's the first assignment that I will give you. Now, we want to talk about the union of a set. The union of a set shows the continuation. It shows the continuation of one set to the other. What did I mean about that? When you have A, you are given a set A, and the elements to be 1, 2. Let me write 1, 2, 2, 3. You have another set B, the element to be 1, 3, 4, 4, 5. And what is A union B? As I've said earlier, that this U means union. Without any repetition, you should be able to write everything. You start from 1 until you get to 5. Don't forget, I said without any repetition. Without any repetition. So it will start from 1, 2, 3, 4, 5. They are not supposed to repeat it. That's what we mean by the union. So it will be 1, 2, 3, 4, 5. Now, I want to say something, and I want you to repeat it without any repetition. 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 3, 3, 3, 4, 5, 6. What did I say? What is the union now? 1, 2, 3, 4, 5, 6. Don't forget, without any repetition. Another one, if you are given a set, a set M, and you have the elements to be 1, 2, 3, and you have another set n, the element to be 4, 5, 6. So m union n will be what? So we have 1, we have 2, we have 3, we have 4, we have 5, we have 6. That's what we call union. And we want to draw the Venn diagram of union. It's like this. If you have m here, the set here, and n, the set, the elements will be here. So the shaded portion is m union n. Okay? That's about the union. We want to talk about the intersection. The intersection shows the relationship between one or two persons. If there's no relationship between them, we'll call it empty set. Now, let's see. You are given a set A to be 1, 2, 3, 4, and you have another set 4, 5, 6, 7. So what is the relationship between A and B? What I mean by the relationship is what is common to A and as well B. 4, that's good. So this is how you are going to write it. A intersection B is equal to, then you write it inside there. That shows the relationship between the sets. And to draw the Venn diagram, this is how you are going to draw the Venn diagram. This is for A and this is B. This is for A, set A, this is for B. The relationship between them, what is common to both of them will be here. So when you remove 4 from A, you have 1, 2, 3. So when you remove 4 from A, B, you have 5, 6, 7. The universal set is here. I think you can see the relationship between A and B. Now let's look at another one. If you are given another set, let me use L now. It says M to be 2, 4, 6. And you have another one, N, to be 7, 8, 10. Now let me ask you, is there any relationship between the first one and the second one? Don't forget that the element in M is 2, 4, 6, and the element in N is 7, 8, 10. Is there any relationship between them? No. So since there's no relationship between them, from the center is empty set. And this is how you are going to do it. Don't forget that this is M and this is N. This center now, you draw 0, you cross it. That's empty set. So you have 2, 4, 6, 7, 8, 10. I think you can see. Okay? Now let's look at a situation whereby you are given an even number. You are given the sets. Let me use X now. The element the element in the set X is even number less equal to 10. And then after S, what is next? Let's make use of P. The element in set P is odd number less equal to 7. We want to find the relationship between S and P. Let's find the relationship between them. S intersection P now. But before you find the relationship between them now, that's what we want to find. You should be able to interpret it. That is why you need to know what even number is and odd number as well. So even numbers start from where, my dear? Yes. That's good. So even numbers start from, let's try to interpret what is here. Solution. Even number from 2, yes, yes, yes. Don't forget that it's less equal to 10. So 8 and 10. Assuming that I remove this one, less than 10, I will only stop at here. Then, what about the odd number now? Odd numbers start from 1, yes, 3, yes, 5, less equal to, yes, 7. Now, they want us to find the relationship between S and P. Look at it. Is there anything that common to the elements in S and as well P? No. So if you want to draw the Venn diagram, you draw it this way. So since there's no relationship between them, you put empty sets here. Then you can write your S here and P here. So what are the elements? You have 2, you have 4, you have 6, you have 8, you have 10. Then here you have 1, you have 3, you have 5, you have 7. Is it hard? You said it's not hard. No problem. So I will test your ability. Let's move a little bit forward. You are given a universal set to be 1, 2, 3, 4, 5, 6, 7. And you are given an element in another set to be 1, 3, 5. Then another one, let's start with this. I want to find A prime. Find A prime. A prime means that you need to remove 1, 3, 5 from the universal set. The remaining one is your A prime. So, can you produce the answer now? I'm listing. So, A prime now is equal to what? Universal set minus A. Now remove 1, 3, 5 from universal set. Remove this, 1, 3, 5. So remain what? 2, 4, 6, 7. Rid of them. That's A prime. Either you call it A prime or A complement. It means the same thing. So Let's try more. You are given a universal set to be, let me still use 1, 2, natural counting number, 1, 2, 3, 4, 5, 6, until you reach 10. That's what it means. Now, you have A to be 3, 4, 5, and you have B to be 1, 2, 5. The first thing you want to find, A, you need to find A intersection B, then B, or let me use 1 instead of writing A to avoid the confusion. Then you want to find A intersection B prime, then 3, you want to find A union B, 4, you want to find A union B prime, then you want to find 4, you want to find A intersection B, A prime intersection B. Okay, now let's see how we want to find this. Then the fourth one, the fifth one now, 1, 2, 3, 4, 5, 6. So it will be A intersection B, then prime. Look at the question very well. You want to find from this rubbish now. You want to find A intersection B. Thank God you know A, the element of A to be this, the element of B to be this. So can you tell me the relationship between A and B? So the relationship between A and B is what? Let's start from here. So can you tell me the relationship between A and B? I've told you that the relationship between A and B means what is common, what you can find in the element of A and as well B. What is it? Thank you, God bless you. The answer is 5. Now, the next one is, I've told you that this B prime means that it's not included. So the answer now will be, what is A? You need to find, and to find this now, A intersection B prime. What is A intersection B? A intersection B prime. You have, this is A and this is B. Can you solve this problem for me? Let me test your ability. You mark this, and I want you to work it. Maybe when we meet next, you let me know. So, what about A union B? Can you tell me A union B? Look at the A and look at the B. A is, the element in A is what? 3, 4, 5. The B is what? 1, 2, 5. So what is A union B? That's good. A union B now. Without any repetition. Is there any repetition there? Yes. Without any repetition, what is the answer? We have 1, yes, 2, 3, 4. The last one is what? 5. Thank you. That's it. Then, what about A union B prime? Before you can find A union B prime, you need to know the relationship between, thank God, A union B is 1, 2, 3, 4, 5. Now, remove 1, 2, 3, 4, 5 from the universal set. The remainder is A union B prime. So when you remove 1, 2, 3, 4, 5, you have 6, 7, 8, 9, 10. That's good. So you are going to do number 2, number 5, and number 6. I've helped you with number 1, number 3, and number 4. Then you should be able to do the remaining ones. Is it clear? Now, we want to go to the application. We have a lot to discuss on sets. They will be taking it one after the other. Upon all the rubbish that we have been solving since morning. So let's try to see how we can apply it to our various fields. I have many questions here. So let me write the question on the board for you to see before we make any attempt to move a little bit higher. Pause. From the given question here, we are told that in a class of 32 students, you should be able to interpret it. In this case, our universal set is 32. The total number of students in a class is your universal set. The population, total number of people that live in a particular area is universal set. The total number of students in your class is universal set. So we are told that in a class of 32 students, meaning that your universal set is equal to 32. And a student can either do government or history. A student can either do government or history. So we have the number of G intersection H now. We don't know yet. A student can either do government or history or both. Now, if 16 students do government, so the number of students that do government now, that's what we want to find. If 16, so we have 16 here, do government. So if you want to write it, this is the number. And don't forget that the set is well defined as collection of objects. The set is denoted with capital letter. Anytime you are solving problem, the set, you must write it in capital letter. That's why I wrote the number of government to be 16. Okay. If 16 students do government, 18 students history. So the number of history